This is the first of two videos about embedding parametric equations into your solid models to make them smart. Today we will start this video using a molded flange with 6 ribs and 6 holes. Let's use the rollback bar to understand the process that was used for creating this part. We see that first there was a boss extrude of a circle, followed by the creation of a new plane, followed by another circle that was then extruded to the first circle. Looks like a draft was also added to that. A hole was then cut through all the solid bodies. Fillets were added to round the edges. A rib was created. The rib was trimmed. A draft angle was added on the rib. The rib was patterned. A hole was added. The hole was patterned. With that understood, now let's add the smarts or intelligence to our design. So we're going to go to the heads up toolbar, the flyout toolbar, go to tools. About halfway down is the equations. That pops up a little spreadsheet table like we see on the screen. I'll shrink it down a little. Within this table, there's 4 sub-tabs, one for the equation view, sketch view, dimension view, and order view. There's 3 columns, 4, name, value equation, evaluates to, comments. On the right-hand side, we see the typical buttons, including an import, export, and help button. The help button is very valuable for learning more or getting answers to specific questions around using equations, such as how to embed if, then, else statements into our equations. At the bottom of the table are a number of checkboxes, such as automatically rebuild, link to external file, etc. In this case, we want to define a global variable first, where a global variable is one where we're just going to create a name for a value embedded in our model that we want to use in multiple ways. Now, if I go to that third sub-tab within the equation table, the one called dimension view, you'll see that one interesting thing I can display with that are all the different labels and their values that are found within this model. That means both sketch values, like dimensions, as well as feature values, such as the number of items in our pattern. So for example, the rib pattern has 6 ribs. We can see that. That rib pattern is dimension 1 in the rib pattern feature. I can see that same information by highlighting it on the screen. And then what I mean by that is I highlight it in the feature tree. So if I click rib pattern on my drawing in the workspace, we see that the 360 degree, we also see the quantity value. So there's 2 different values, D3 and D1 of the rib pattern. These are important to have displayed on the screen because we can then use those to auto-populate fields within this equation table. So in the first column, as I mentioned, I want to create a global variable. Let's name this global variable ribs. And if it's a character string, we should put it in quotes. If you don't, it'll show the word in red. But if we hit the tab key or we space, SolidWorks will sometimes automatically put the quotes in for the item if it has a feeling about what you want it to do. So I'm going to just click into the second column, and you'll see the red word ribs change to one with quotes around it, and it went from warning of a red text to standard black text. Now, notice I've got my cursor flashing in the value equation table. Cell in the second column of the equations table. If I now click on that numeric value of 6, it pre-populates that label information in this, and then there's a green check mark that if I click that, it says it evaluates to 6. So it was a fast way by just highlighting the feature tree items and getting them to display on the screen so I could click them to auto-populate some of these cells. I would have the option as well, though, to just manually type in. I could have put equals, quote, D1 at rib pattern, close quote. That's the same information that I see by clicking this dimension view and scrolling through my information to find it. So I have two ways of doing it, but it is much quicker to just highlight something on the screen in the feature tree and then select that particular label or feature. And so now what we can do is use that global variable that's called ribs in specific equations that we want to add to our table. So our first one is we want to link together the number of ribs to the number of holes. Because if I don't do that, if I just save my table right now, and I go and click on a rib, and I change this value of 6 to, well, let's not make it 12, let's make it an odd number like 9. You will see there will now, when I rebuild the part, there's 9 ribs, but there's still just the original 6 holes. So what I want to do is create an equation that will link the number of ribs to equal the number of holes. So I go down to the equations row in the equations table. I highlight on my feature tree the hole pattern. I put my cursor in that first equation cell, click on the 6th, and it says D1 at hole pattern. I can then go over and say I want that to equal the number of ribs. Now what happens if I say OK? Now if I change my number of ribs to 9 like I did a few moments ago, and I hit OK, and I rebuild, now I have 9 ribs and 9 holes. The issue now is the holes aren't centered between the ribs, so I go back to Tools, Equations, and I have to come up with another equation. This time what I want to do is I want to modify this 30-degree angle, and I want to make that a dynamic angle. So I'm going to do the same thing I did before. Click, in this case, the second cell underneath equations. Click on the 30 degrees, which is labeled as D2 of sketch 6. Okay, I'm now going to set that equal to my ribs, but it's not the value of 6 that I want to set that to. I want to set it equal to 180 degrees divided by the number of ribs, which in the case of 9 ribs would be 20 degrees. So now what I've just done, I can, change my number of ribs to 15, and we'll see that we have 15 holes that are now equally spaced. Do it again, go to the other extreme. Let's make it just 4 ribs. 4 ribs with 4 holes, again, each equally spaced between the ribs. I did that once again by going to the equations table, defining a global variable ribs, and then two equations that use that global variable. And that concludes this video. Thank you.